Hi everyone, my name is Sarah. Today I'm going to talk about how we can use R Markdown to produce our reports. I'm going to talk about roughly 10 minutes on R Markdown, and then we will move to GitHub, and I will introduce Git and Github to you. So how many of you have used R Markdown before? Oh, cool. Like this half. Okay, great. Markdown is basically a tool that you can convert your text to HTML outputs, and R Markdown is a flavor of Markdown that has all the good advantages of Markdown, but in addition to the features of Markdown, actually with R Markdown, what you can do is that you can easily embed your R codes into it, and the output of R Markdown is not only HTML as it is in Markdown, but you can produce HTML, PDFs, and MS Word documents with R Markdown. So as I told you, the really important advantage of R Markdown is that you can embed R codes into a Markdown document. So why this is useful? Because imagine that you want to produce a report, and then in your report you want to put the result of the plot that you generate as the output, and then what you have to do is you have to create the plot separately, and then you have to save it somewhere and then put it in your report. So up to now, this is fine. Okay, you will produce the plot, you will save it, and you will include it in your report. But then, what if your data set changes for some reason? What you have to do is that you have to generate the plot again, and then again save it, and then use it in your report. But if you use R Markdown, what you can do is that you can actually write your code inside the R Markdown environment, and when you knit it, the output of the R Markdown will automatically be updated with the change in your code. Does this make sense? Okay, so what I want to do is that I want to create R Markdown here, and we can see the output together. So, okay, it's a little bit small, but I hope you can see it. So there is a small, so we open the RStudio, there is a small plus sign icon here that if you click on it, there is an option to create a R Markdown document. So if you click on it, then it will ask you to write the title. So you will write something that, okay, my report, and then you will write the name of the author. Let's say I want to generate a PDF. You can choose whatever you like from here, and then okay, so here you can see a preview of R Markdown file that R generates for you. You can see the title here, the name of the author, the date that it generates automatically, and the output of this file is going to be a PDF. So let's run this. So there's an icon here. It's very small. It's called knit. If you click on it, it will ask you to save it. Okay, I'm going to save it somewhere. Let's say in the desktop. Okay. Here is the report that R Markdown created for us. So you can see that it has a subtitle, you can write your texts here, and more importantly, you can embed R code here. So you can see that this cars is an available data set in R that you used to to see the summary of this data set. And what you can see here is that you can see the code here together with the result of the code. So this is really useful when you want to produce your reports. The only thing you have to do is you have to just type your code as you will do in R usually. I will tell you how to write the code in R Markdown. And then once you knit it, you can see the code and the result of the code both in your report. This is very useful because if the dataset cars here changes for some reason in your future work, you don't have to be worried about the result of the output. It will automatically generate the changes, and it will update it to the latest changes that have been made to the dataset. So let's go back to our R Markdown file and see what we can talk about here. So in order to write a title here, all you have to do is you have to write 2 hashtags and then write your subtitle actually. With one hashtag, you will have a bigger title. Here you can write your text, and then if you want to embed the R code into R Markdown, you have to put 3 backticks like this, 1, 2, 3, and then a curly brace. I forgot the name, I wrote it here. So a curly brace like this, and then write R here. Oops. Okay, and then end it with 3 backticks like this. Then give it a name like chunk name, and then here between 2 backticks you can write your code. So let's say we want to see the head of cars, for example. Okay, let's go ahead. You can see head of cars, you can see the code, and you can see the output. There are some cases that you really don't want to include your code in your report. It's silly. It's maybe like 20 lines of code, and you don't want to have your codes into the report, but you are interested to show the results. So if this is the case, then all you have to do is to add an option here which is called echo and set it to false. This echo equal to false will prevent the R Markdown from showing the code in the output. So see, you cannot see the line of code which was here previously, head of cars. But here, for summary of cars, because we didn't set echo equal to false, you can see the code and the result. Okay. What if you only are interested to show the code in your report and you're not interested to show the output of the code? All you have to do is let me double check it. Results, yeah. So you have to set the results equal to hide. This will hide the results and will only show the codes. So if we knit it, you can see the code here, head of cars, but no the result of the head of cars is not shown here. Any questions up to now? Okay. The last thing is about including plots in your reports. Let's say we have a data set called pressure, and then we want to plot it, and then we set echo equal to false so that the code will not be shown in the R Markdown. And then let's just see this plot so that we can make some changes to it. Here is the plot, and the code is not shown here. So let's say we want to change the width and height of the plot. Okay, let's say we want it to be 3, width height equal to 3, and we want to add a caption to our plot. So here we choose, this is my caption, okay. So you can see that the size of the plot changed, and a caption is added here for this plot. Yep.
Sorry, is there an easy way to add a long caption?
Can you say it again?
Sorry, is there an easy way to store a long caption?
Oh,
somewhere?
Yeah, you can
store it as variable.
Yeah, they can do fig.cap equals a variable.
Okay, but how's the scoping work for these markups? Define variables globally, and then they turn up in the appropriate places in Markdown, so you have to be specified in each of these blocks.
You mean here?
Yeah. So if you were going to put the caption in a variable, you have to define the variable in that same chunk where you're going to need it.
Yeah, I think I saw an example yesterday that I don't remember it exactly, but yeah, I think they defined the caption as a variable here inside the chunk, and then they defined it as something like cap, and then they defined it as a character here, and then they called it here. I'm not pretty sure. Are you?
It's global context. The snippets, they're in global context.
Yeah, I think so. Maybe this will work. I'm not sure. Not sure. Yeah, it worked. Yeah. So yeah, you can define a long caption here and define cap as that long caption and call cap here. Okay, then I provide a document for you that you can access to the document if you go to the GitHub here, the GitHub repository May Institute. Somewhere here, okay, here I introduced 2 references for you to learn more about R Markdown, and you can also create posters with R Markdown, which is really easy, and I again provided a link for you that you can go ahead and read about it yourself. But we don't have enough time, so I just briefly introduced R Markdown. Okay, any questions?
For that chunk name, besides to name it, what other utility you can get for the chunk name?
Oh, you mean why we have to name it?
Yeah, obviously, if you name it, it's easy to read, right? But besides that, is there other application that you take advantage of that?
Yeah, I think if you want to call it later in the document, then you can call the name of the chunk. Or for example, if you, I think if you define the caption, so this caption will generate a figure that has a caption figure 1 and the name of the caption. So it's figure 1, this is the caption, and then if you want to refer to this plot, I think that you can refer it by the name of the chunk, if I'm correct. Any other questions? Okay, cool. So now let's move to Git and GitHub. Okay, how many of you has used Git before? Okay, many. So first of all, I want to let's make it bigger. Are there any PhD students in this room? Does this sound familiar? Well, this comic is from the phdcomics.com, which is a really cool website. I don't know if you have any chance to visit it. So this will have lots of comics about the life of a PhD student. This is one of them that I want to use as the intuition to tell you why we should use Git. Okay, there are many times that you think that the paper that you're working on or the project you're working on is finalized, but then you will show it to your advisor or to your manager, and then he or she will ask you to revise it, and then you will revise it, and because you want to keep the original document for any reason, you will rename the file to something else. So the first name was final, the second name is going to be final revision 1 or final revision 2, and then this process happens again and again, and the advisor or the manager asks you to revise it, and then each time you will save the document with different name. So finally, the final one is really funny. It's final rev 22 comments correction something why I come to grad school. So yeah, then finally your paper will be finalized. But then assume that 1 year will pass, and then you want to go back and find your final version of the paper or project. You will face lots of files with different names, and all of them has the label of final on them. So you don't really remember, okay, which one was actually my final version. This is the first situation that I described for you. Let's talk about the second situation. Assume that you're working on a project and your project is in a good state. And then you want to make some changes to project, you want to implement some new features and change the code, but you're afraid that you may mess everything up. So in order to be safe, you will you will save a copy of the project somewhere with a name so that you make sure that, okay, the copy of the good state project is somewhere safe in my computer, and then you will change the original one, and if something bad happens to the project, you encounter errors that you cannot solve, or things don't go as well as you wish, then you had an option. You saved your file somewhere else and you can go back to the previous version of the project. But what is the disadvantage? Can anyone tell me? Yeah, okay, as you may think, a project may take a year to be completed. And if you want to do this process every week that you want to make changes to the project, then you have to save different versions of the project somewhere on your computer with different names, and then it's really hard to follow up the process of edits. So what I mean is that it's really hard to follow what changes was exactly made from the previous version of the project to the current version of the project. You have a bunch of files with different names, and you know that all of them are the previous versions of the project. But how can you follow up the changes? How can you track the changes? That's the disadvantage of this way, and also it will occupy the memory of your computer as well. And the third situation, which is the most important one, is that when you want to work on a project with a team, assume that you are 2-3 people working on the same project, and then each of you want to make your own changes. And so you make some changes, your teammate makes some changes, and then at some point you have to tell each other that, okay, let's see, I add this function, I make changes in this line of the code, I deleted that part, and then she has to tell you that, okay, I made these changes, and then you have to manually apply the changes that your teammates have done on your own system, which is really frustrating. And this is really important, and maybe we can find some solutions for the situation 1 and 2 that I described for you, but this situation 3 is really frustrating. If you don't use a version control tool, then it's almost impossible. Okay, so that's why we want to use Git. So Git is a software that can be installed locally on your computer, and you can handle the version control of your files easily. And what I mean by version controlling is that you can take a snapshot of your files every time you make changes to them. So every time you made some changes to the project, if you commit your changes, Git will take a snapshot of the project at the moment of the changes. And then the benefit is that your project will be updated to the latest version, and you will always have access to the previous versions easily. And you can also follow the changes easily. For example, here, this is the commit environment of RStudio that I will show you later. But assume that a person has deleted this line of code, which is shown here by red, and then added these 2 lines to the project. And once he decided to commit the changes, he can easily see what changes has been made to the project. He can visually see that, okay, this line was deleted and these 2 lines were added to the project. And even if you are colorblind and you cannot see the colors here, the RStudio provides 2 columns here for you. The numbers that are written on the left column show the rows of the code that are deleted, and the numbers that are written in the right column shows the rows that were added to the project.
Are there best practices about the volume of changes you should make or not make in subsequent commits?
Are they what?
Because, I mean, you could just change one letter and that will show up in Git as a modification to the code, right?
Yeah, but you don't have to commit. If you, for example, if you just add 1 line of code, you define a variable, you don't have to commit it. So.
No, I understand that, but how is there a sense publicly for scientific purposes how much, what the magnitude of the changes are that are reasonable to go into a single commit?
I think it depends on your feelings. I don't have any answer for that. Okay. Any other questions? Okay. And then, what is the definition of a repository? So, when you start a Git project on your computer, so you will install the Git software on your system, and then you're going to store the whole project and all the history of the project locally, and the storage of the project and all of its history is called a repository. So once you install Git on your system and you store your project on Git, the repository is a local place on your computer that's gonna store all the project and all the history of the project. So as I told, if you make some changes and then you decide to commit it to Git, Git will take a snapshot of your file when you commit the changes. And you can see the process of committing as a chain in this graph. So this is the latest commit that you have done. This is the previous commit. This is the one before that. And so in RStudio or any other tools like GitHub Desktop, or if you click on these small nodes, you can actually see exactly what changes has been made to project from the previous comment to this commit, not comment, to this commit. And then you can easily revert to the previous version, and also if you make something wrong and the project is messed up, you can easily convert the whole project to what it was in the previous version. So that's also one of the good benefits of Git. Okay. So all that I talked up to now was done locally on your computer. The Git was installed locally on your computer, and the commits and everything was done on the computer. So what if something happens to your computer? What if someone stole your computer, or something happens and you lose your data? Then you have to make sure that your project is saved somewhere, so that if this situation happens, you will have access to your project. Then you will probably need a remote server to save all the project and all the history of your projects there. And one of the remote servers that can work really well with Git is called GitHub. So GitHub is a website, it's like a remote server that you can store all the information about your project and the history of it there in the GitHub, so that you don't have to worry about losing your data. It's all there on the GitHub. So there's a definition called push that you will hear a lot. This push means that when you make a commit in your repository, if you push the changes to the GitHub, then all the changes will be moved to the GitHub server. So pushing is simply sending all the information, all the changes from your local repository to the GitHub server. So one of the advantages is that, okay, you will have your data saved somewhere, and then one of the important advantages of using GitHub is that it will help you to work with a team easily. How is this possible? So, okay, assume that this is you, this is your teammate, you both have your own computers, you both have your own local repository on your computer, and there is a GitHub server that the project is there, and all you have to do is that first of all, let me introduce the definition of pool. If any information is on the GitHub server, by pooling, you will receive all the updates and all the changes, and your project will be updated to the latest version. Is pool clear to everyone? Okay, so now back to our scenario. So you and your teammate are both working on the same project, which is available on GitHub, and then you want to make some changes to the project. Before you start changing anything, what you have to do is you have to pull the information from GitHub. This means that your files will be updated to the latest version, and then you can make some changes and commit your changes and then push your changes to the GitHub server. Now assume that your friend wants to work on the project. All she has to do is that first of all she has to pull the information from GitHub so that she will make sure that her project is updated to the latest available version of the project in the team, and then she can make changes, she can commit the changes, and once she's done, she has to push them back to the GitHub so that everyone have access to that. Is this clear? Nothing will happen. So whenever some yeah, if everything is going fine, there will be nothing to worry. But then if, for example, your teammate makes some changes at the same place that you are making changes, and then she pushes her changes first, and then you are the second one who want to push your changes, Git will not accept it because there are already changes at the same place that you are trying to push your changes. So Git will give you an error and will tell you that, okay, there is a conflict exactly at these lines. It will show it to you. You have to take a look. The person who receives the conflict is always responsible to solve it. So it will show you the places of the conflict. You have to go there and see what's happening and decide what to do. And I'm going to make a live demo of conflict and solve it here in the class. It will all show as 1 point, but in different places. Yeah. Yeah, that's not good. You have to, you don't have to spend 3 days and then decide to push your changes. It's better for you to push like 2-3 times a day even. It's not safe to push after 3 days, I guess.
But it'll carry over all of his commits. Like when he pushes and he's made 5 local commits, there will be 5 remote commits for someone else.
I didn't get it.
Like if he makes 5 commits locally.
Locally, okay.
And he doesn't push.
Mm-hmm.
He just commits locally, and he says, okay, I'm gonna push.
Mm-hmm.
To the server. If no one's pushed and there's no conflict, someone will then pull down 5 new hashes, 5 new commits.
5 new commits, exactly.
There will be 5.
There will be 5 new commits.
Yeah.
Yes, yes, yes. Okay, we have 20 minutes. So I'm gonna quickly go and tell you how to do the things that we learned here, and then we will not have time at the end of the class. I was hoping that we have time so that we can all do it together, but I guess I'll just show it to you. So first of all, what you have to do is that you have to install Git on your system, which I provided the links in the document on the GitHub. And then let's go step by step and make a repository. So after you install Git on your systems, you have to go to the GitHub website, github.com. So I'm already signed in, but if you're not, you have to sign in, or if you don't have a GitHub account, you have to sign up for yourself. So I already have a GitHub account. So here there is a button called New Repository. If you click on that, you can create a new repository. So let's say my repository is my first Git try. The description is that I want to learn Git, and then you initialize it with a README. So a README is basically a piece of note that your GitHub can have, and then everyone who wants to visit your GitHub website, they can read this README and understand what the project is about. So you can introduce your project into this README note that it will provide for you, and you will go ahead and create your repository. Okay, now the repository is created for you. Oh, what a name. Okay. Then there is an option here, clone or download. Click on it. There's a link. This is the link of your repository. Just copy this link. Okay. And then we will go back to RStudio. So here we will create a new project. So we will hit on File, New Project. There is an option here, version control. Click on that. Okay. There is an option here for Git, clone a project from a Git repository, which is what we exactly want to do. Click on that. Paste the URL that I just copied here. And then choose a place to save your project. Here, I'm gonna open it in a new session and then create the project. So as you can see, it cloned the repository that I created in GitHub here in RStudio. You can see the README file here, which I wrote, I want to learn Git. You can see it here. Okay, let's say we want to create a project and work on. So we will create an R script as usual, save it. In this funny repository, and then let's write some codes here. Okay, I'm gonna save it first. Save. And then there is a small Git icon here, really small, but if you click on it, there is an option for committing. So now assume that I decided that, okay, I made the changes that I want. Now I want to commit the changes. So click on that. This will appear here. So where did you make changes that you want to commit? You made changes here in my project.r. So here, select my project.r, because here is where you want to make your commits. You can see two green lines, which is telling you that two new lines were added to this project. Nothing were deleted. Only two files were added. So you will write a small message here, like I defined two variables, and make sure that you write nice messages and informative messages so that you can follow up later when you need it. Okay, then I'm going to commit it by clicking on this small commit button. it says that okay, it's fine and it's committed to the. So is it now on the GitHub website? No, it's in my local repository. I have not pushed it to the GitHub server. So let's go ahead and push it to GitHub. Here you have to select push branch. Okay. Let's make another line of code. Save it. Then let's say again we want to commit the changes. Select my project.r here. Actually, I didn't delete this line. I don't know why. I don't know why this is shown as red here. Do you have any idea? It shouldn't be red because I didn't delete it. But anyhow, like I defined W, committed, and let's push it. Uh-oh. Okay. Let's go to the GitHub website and see if, okay, you can see the project is pushed successfully here. My last commit is here. If you click on this, you can see the changes here. It will show you that, okay, these were added to the.
Oh, it's because you had a new line.
But it wasn't a new line.
No, you added a new, like you added a return character at the end of the second line.
Oh, that, okay, yeah.
Because there's a return character at the end of the line.
At the end of, oh, so this one is no longer the end of the line. That's why it's.
Yeah, it's the same line, or it's like actually if you look at, I think that's like a prohibitory symbol, and then no new line at the end of the file.
Okay, yeah.
So that because you added, it's not saying you deleted it, it's saying the red is you changed it.
Oh yeah, and maybe that's why this small red icon is shown here.
Text it as like you have changed the line because you added white space.
Mm-hmm. Yeah. Okay. So far so good. We learned how we commit the changes, how we push them to the server, and then so do we need to pull anything if we are the only one who is working on the project? Probably not, because we are the only one who is working on it, so we have to only push the changes. But if we have a collaborator, if we are working on this, my first Git try project with a collaborator, then other than pushing, we have to pull and push and do this all the time while working on the project. So in order to add a collaborator to the project, there is an option here, settings. If you click on that, you can see the collaborators option here. Click on it. It will ask you to write your password to make sure that this is you. Okay, so here you have to add the username, the GitHub username of your collaborator. I'm gonna add someone who I know, like this. Okay, and then you will click on add collaborator. Once you click on this, an invitation will be sent to your collaborator, and then he has to look into his email and accept the invitation, and then he will be added to this project as well as you. But we don't want to do this right now, so I will play with myself. I will assume that I'm two persons, and I will make some changes here on the GitHub website, and then I will go back to RStudio and I will pull the changes so that you can see how this process is working. Okay, let's assume that your collaborator, oh, not this one, made some changes. So he will define k as like 2 times x, and he will commit it. Okay, once I commit the changes, this means that I commit and push because I'm already doing it on the GitHub server. I'm not doing it on my local repository. So this means that, so assume that my collaborator add this line of code to the project and then commit and pushed it to the GitHub. So this line is added and pushed to the GitHub. So now you will open up your laptop, you want to work on the project. The first thing that you have to do is that you have to pull the changes from the GitHub to make sure that your project is updated to the latest version, and make sure that if your collaborators has made any changes, you have all of them here on your version as well. So you have to click on this small Git icon and pull branches. Okay, you can see that this line was added to the project.
Locally notify you if your commit series is behind the one on GitHub?
Yeah, I didn't get your question.
He was asking if you accidentally commit ahead of the master branch on the server, will it notify you? And the answer is yes.
Oh,
That won't notify
no.
you until you pull.
Yeah, well, until you actually.
Oh, you mean before?
Until you try to push. If you try to push and someone else has pushed already and it went through, you will get blocked, and it will tell you you need to pull before you can push because you're behind one command. But you won't know that you're behind until you try to push or pull.
Yeah, if you try to commit, there is nothing wrong with it. You can commit in your local repository. But once you try to pull or push, then if there is a conflict, it will tell you. But commit is always fine. Okay, as you can see, when I pulled the branch, this line of code that my collaborator added to the project is appeared on my local repository. So I can see the changes that he has made, and then I can again try to like add something else, and then once I'm done, I have to commit it, and then I have to push it to the GitHub server, and then my collaborator has to pull the changes and make her own changes and commit and push it to the GitHub server. And this process has to be done again and again. Okay, so for the last time, I will commit it, and then I will create a conflict scenario and I will solve it. Okay. Okay, let's say that my collaborator changes the 6th line of the project. She will type plot of x and y, and then she will commit it. So she made changes in line 6, she committed and pushed it to the GitHub, and then, so it's on line 6. So now you open your laptop and you make changes on line 6 before actually pulling the changes from the GitHub. So she added plot of x and y, and you we'll add this. You will save it. You will commit it. Something, added the variables. Okay, nothing bad happened. You successfully committed, although you changed at the same place. But because you just committed locally, Git will not understand that that your teammate has made some changes exactly at the same time. So if you try to push your changes to the GitHub server, it will produce an error for you, because it doesn't understand, okay, at line 6 there was already a plot, and then now this new thing is appearing. I don't know what to do. Let's try to pull the changes from the GitHub server. It will tell you that the conflict is happening, and it will exactly tell you where the conflict happens by telling you you have to look between these two lines. This is the head and this is the tail of the source of the conflict. So what is above these lines and below head is always what you have written. What is below the lines and above these signs is what your teammate has wrote. So now you have to decide. Okay, you can see that, okay, I have this line of code, my teammate added this, as you can see, and you have to decide yourself whether you want to keep both of these lines or to delete one of them and only keep one. Because you are receiving the conflict, you are responsible to solve it. So my decision is that, okay, I'm gonna keep both of them. So I'm gonna delete these signs here. And as you can see, there is no reason for conflict anymore, because each line of the code is now in different line number. Okay, we will save it. We will go to Git and commit it. And you will write, okay, conflict solved. That's fine. And you will push the new changes to the GitHub. That's all. Any questions? Okay, that's all I wanted to talk today. I provided some resources for you at the end of the presentation, which you can go ahead and read more about Git and GitHub. And that's it. Thank you.